You have a complex project to finish and a powerful AI model at your fingertips. The immediate human instinct is to ask the machine to do the whole job at once. Draft the complete report. Write the full marketing plan. But by forcing the model to handle a sprawling task in a single pass, you spread its computational attention dangerously thin. It has to juggle competing priorities, balance out multiple sections, and navigate the entire document simultaneously. The model produces a competent, functional draft that touches every necessary base, but it lacks any distinct impact. It feels generic because the machine is devoting equal attention to every section at once. You likely provided specific details about your unique situation, but that context gets washed out. It is forced to compete with the vast mountain of standard, generic structures the model relies on when it lacks the mental space to think hard about a specific problem. When you demand a finished, complex product in a single sweep, you guarantee a result that is the mathematical average of everything the machine has ever memorized. There is a more effective way. You intentionally call a halt to the actual generation of content, focusing entirely on building the bare structural layer. This is known as the decomposition pattern. It is the practice of looking at a massive goal and mapping out its natural subtasks into 3 to 5 distinct, focused pieces. Instead of asking for a complete draft right away, you prompt the machine for frameworks, outlines, and constraints. This establishes a highly defined context that the model will draw on later. This document outlines the method. Generating a structural outline first forces explicit architectural choices, locking in a central argument before any prose is written. The output is deliberate architecture. The model has carefully plotted how the product will flow, replacing generic guesses. It feels like preliminary work that delays your real output, but pausing to map out this structure is the highest leverage work in the entire workflow. It shapes the quality of everything that follows. With the structural scaffolding firmly established, you dramatically narrow the scope of the task. You move away from the broad document and isolate a single fragment. Back to the document, we see this in action. You feed the machine structural context, restricting it to drafting only the introduction. The machine dedicates all computational attention to this smaller problem. Output is significantly sharper, and you repeat this process for every remaining section. This method produces better prose, but it also creates a hidden advantage over the single prompt approach: localized debuggability. In a monolithic prompt, changing a single section often requires the model to revise the entire document, which frequently loses the parts that were actually working. By decomposing the task, you can re-prompt a single flawed section while keeping the rest of the verified work intact. Narrowing the machine's focus sharpens the individual pieces of thought and makes the refinement process tractable by isolating mistakes to a single, easily replaceable brick. At this point, you are looking outward at a collection of newly generated, highly focused fragments laid out in front of you. But pieces born in isolation carry an inherent flaw. They do not naturally fit perfectly together. The machine drafted each section without experiencing the detailed line-by-line flow of the surrounding text. This creates a coherence risk. The connective tissue and the natural transitions between your separate ideas are missing. The final step of this workflow relies on purely human labor. You must tend to the seams, knitting the sharp pieces together and ensuring a consistent tone across the entire document. The decomposed workflow shifts your effort from complex prompt engineering to rigorous human editing. Spending 30 minutes of your own time editing high-quality fragments yields a noticeably superior result than passively accepting a flawless, completely mediocre draft generated in 10 seconds.